Hi, everyone. This is Rob. We're going to be starting the webinar in about a minute or two. Thank y'all for joining. Hi, everyone. This is Rob. I'd like to welcome everyone to the Data Architecture Virtual Chapter Group. We're going to go ahead and start. It's 1 p.m. now, and I would like to welcome Sreevani and Doug to the webinar for the Data Architecture Virtual Chapter. I'm the leader, along with Kenny, and if y'all ever have questions, you can email us at thedataarchitecture@pass.org. So, upcoming webinars. Tim is going to be presenting we have next month an introduction to Azure Managed Instances, and following that up later it will be big data clusters. So those are some really cool webinars. I hope you all can join us. We'd like to thank HVR for sponsoring our Data Architecture Virtual Chapter Group. As always, this wouldn't be possible without great sponsors, and we're very fortunate to have them. If you're getting a chance to go to Summit, here's the discount code. Please use it. You'll save some money, and typically, if enough people use the code, we can give away a prize, like maybe a free trip or something. I don't know. Sometimes they give us some prizes, and we're able to raffle them off, and that's always exciting to let someone have a prize. Elections is coming up, so if you want to vote, please vote. The link's right here. Going on. Passion Award is also a great award for people that do a lot in PASS. You can learn more at the link below. They're still accepting applications for the Passion Award till September 25th. Here are some other virtual chapter meetings coming up. PASS has a lot of virtual groups, and it's really kind of cool. You can get free training, and here's just a sample of what's upcoming this month. And you can see there's a lot. I've counted 8 so far, 8 meetings, a lot of cloud meetings. Look at that. That's some good stuff. SQL Saturday. So if you have an opportunity, you've never gone to SQL Saturday, it's a pretty cool, amazing event where people come together and just have free training. So here's some in Canada and in various places, and check it out. So without further ado, up to our webinar today, Modernizing Your Approach to the Data Warehousing. And with that, I'm going to turn it over to Doug. Is that correct?
Yes, Doug, that
okay,
works.
Great. Yeah, that'll work. Great. So I'm going to change the presenter right now to you, Doug, and we're going to be watching your screen for a while. Oh, by the way, just one quick note, the webinar is recorded. Please hold your questions to the end, and if we can't get to your question, I'm going to make a note and make sure all of the questions get bundled up and sent off to them, and y'all, they will answer. I'm sure they'll answer the questions for you. So thank y'all for coming today and presenting.
Thanks, Rob. Well, my name's Douglas. I work for a company called Warescape. We build data warehouse automation software, and we partner with HVR, the guys that are sponsoring this webinar. And together, they enable companies to modernize their data warehouse environment. So we're going to go and have a look at why we need to modernize the data warehouse. Then we'll have a look at what data warehouse automation provides, how it fits in with agile development within the data warehouse, and how HVR or CDC can work with automation to give a better overall solution. There we go. Well, 10 years ago, I used to start a presentation about data warehousing with a statistic from Gartner that 80% of data warehouse projects failed or went over budget. And today, I don't think it's got any better. It's still that much of a problem. Data warehouse projects take too long and are too hard. And the problem is not really a technical issue. It's basically a conflict between IT and the business. The business wants data now and is impatient for it. And IT wants to deliver only data that's right, that's correct. And both sides are right, but both sides end up being frustrated. Well, I'm going to talk to you about data warehouse modernization using automation tools that solve a lot of the issues in delivering data warehouse projects. And at the same time, allowing the team to modernize the platform, the architecture, the tools, and the approach of the data warehouse. And of course, we're really excited to partner up with HVR because they extend what Warescape does as an automation tool to allow us to pull data in more rapidly with lower latency from a greater range of sources than we can do with just Warescape. Well, we're seeing a trend in our customers where data warehouse teams are under increasing pressure to modernize their data warehouse, to cope with data types, new data sources, and larger data volumes. They need to take advantage of new platforms such as cloud databases like Azure DW, or Snowflake, new tools for automating development, new more agile approaches for project delivery, and new architectures such as Data Vault to cope with the increasing demands from the business and leverage the economies and scale that modernization brings. But while they do that, there's no respite from the business. There's no respite while IT figures out these new technologies, how to apply best practices, because the best practices are going to change. From your on-premise SQL Server to Azure DW, you're going to need different approach or different standards, different best practices applied to get the best out of that target platform. And platforms like Databricks might be cool and excellent, but they're not going to deliver projects faster. Not only is the data warehouse platform likely to move to the cloud, but also source systems are moving there too. And that presents new issues when we try and pull data into the data warehouse, probably from a new set of application APIs that we have to figure out. We're also going to have to deal more and more with unstructured data, so data delivered in JSON or, God forbid, XML format. And often these new systems can create much, much more data. And while we're contemplating all that, there's also often audit requirements and laws coming into place where we need to make sure that we can reconcile everything and expose all the history and lineage to pass audits. And all the while, the IT team stays the same size. Now, I've worked in data warehouse projects for the past 20 years, and the biggest impact on a successful project I found is agility, working with the business in tight iterations, and being able to refine our design through collaboration with the business users. And this is hard to do with traditional projects. Firstly, data warehouse teams are often divided. They're divided into separate roles like business analysts, modelers, ETL developers, testers, and each one of these roles use a different set of unintegrated tools and hand over from one team to another with documentation, requirements documentation, source to target mappings, test plans, release plans. And this all together, when you look at it, is quite a clumsy process. And during development, data warehouse data processing is built by hand. It's usually written in SQL or an ETL tool like SSIS or Data Factory based on the ETL mappings from the modelers. And that's not always fast. And this is a pain during initial development, but really hurts the project during iterations or rework when we need to adjust the target model and mappings to a better understanding of the data and requirements during the project. And because code is manually written, it does not often have strong standards applied to it. This makes troubleshooting and support much, much harder. In fact, the dependencies in code often become so hard that really only the developer understands it. It becomes sort of a tribal knowledge, which is a scary prospect if it becomes a business critical system. And of course, when we ask IT professionals about their documentation, particularly as it relates to the data warehouse, usually people start shuffling about and looking at their feet because there isn't any, or it's terribly out of date. And we do need that documentation to help people navigate the data warehouse and to help the IT team support the data warehouse. So all in all, we have a slow, hard to maintain project that's usually poorly documented. IT is working hard, but ultimately frustrated, and the business is frustrated because they're not getting access to the data as quickly as they'd like. So how can automation help? We believe data warehouse automation, coupled with CDC, goes a long way to solving these issues and will be crucial in helping IT modernize the data warehouse. Automation is all about automating the manual tasks of designing, developing, deploying, documenting, and operating the data warehouse. We want to eliminate the donkey work of building the data warehouse and concentrate on delivering the right data in the right format to the right people. First and foremost, data warehouse automation is about productivity. It speeds up development, and this allows the team to be agile, and that gives the team the greatest chance of success. An automation tool uses reusable design and processing patterns and metadata to accelerate the build of the data warehouse. Our goal is, if it can be automated, it should be automated. This speeds up development, but it also speeds up redevelopment. And because it's following a pattern, it's very consistent. For example, type 2 dimension processing should be identical across all type 2 dimensions in an ideal world. No matter who's driving the keyboard, the code should look the same. Well, of course, the attributes might be a bit different dimension to dimension, but the code should follow a very standard, consistent format across all the type 2 dimensions or type 1 dimensions or data vault tables or whatever tables we're trying to build. The pattern applied should be the same. An identical code is much, much easier to support. You only have to learn one layout of the code to support all of them. And because the developer is not in the weeds of the code, because the code is generated, the new platforms and languages can be used much, much quicker, leveraging the best practices and patterns optimized for that specific platform. The ability to rapidly make changes, rapidly build and then make changes efficiently lends itself to agility. This agile development requires the team to iterate at a cadence of change that keeps the business engaged. It's no good iterating slowly because the business can lose engagement, and we need the business to be engaged during the project. And this rapid iteration, this agility, lowers project risk by bringing the business into the team, allowing them to change their minds once they see the data. And that's very, very useful. And this is why automation is crucial to modernization. We can be agile, we can add in or switch new platforms or architectures or technologies very rapidly. And finally, the metadata can be leveraged to generate documentation for end users and for the support staff. Automatic documentation, which is really every developer's dream. They don't have to do it themselves. Now, I mentioned earlier that automation relies on reusable patterns. Well, in data warehousing, of course, there are patterns everywhere. There are patterns that we can use to automate the design, development, and operations of the data warehouse. We have ingestion patterns, processing patterns, aggregation patterns, patterns for key generation, patterns for managing time variance, patterns for key lookups, change detection, indexing, storage, data cleansing, the adding of housekeeping columns. There's patterns everywhere in a data warehouse, and it's these patterns that enable us to automate a lot of the work in building out a data warehouse and remove the hand-built nature of data warehousing to standardize the implementation. When we look at a typical processing pattern in a data warehouse, it can be described as layers of processing. Normally, we start with data ingestion, the extract and load of data from source. We need to apply delta loading strategies. And this is a perfect use case for CDC-based replication from source into a landing zone of the data warehouse, because this can be a real pain without CDC, or when we have to pull data from an application such as Salesforce or SAP. Then we normally move through to the next layer where we're applying hard data rules, applying cleanup rules such as data type conversions, deduplication, null handling. And we'll publish data into a foundation layer or atomic layer of the data warehouse. And this is persisted either in a raw format, matching the source, or reformatted into a third normal form. Or nowadays, we find more and more frequently a data vault design is used in this atomic layer of the data warehouse. We see the rise of the data vault design becoming more mainstream for the atomic layer because of its natural ability to integrate data across source systems, its built-in time variance, and its ability to support modular or agile design. And this allows a team to add new sources or modules to the data warehouse without having to redevelop or change tables that have already been built. Data Vault also keeps a auditable record of source data and source data changes, which is great for data compliance and audits. And then from the foundation layer, we often apply then the business rules and reformat the data, adding a business perspective and business transformations, preparing the data for the end user layer of the data warehouse. And this is where we're exposing probably a star schema or some flat tables that make it easy to navigate and access in a BI tool. And really, when we look at this diagram, it's usually the last three layers, the business transform, the end user layer, user access layer, which we require more agility. That's where agility is most important because it's providing a business perspective to the data. And it's then that we need to collaborate and engage with the business analysts or business users in order to give them the design that they need. And underlying all of this, we can see there's metadata. Metadata ties all of this together in an automation tool. Stores not just info to build tables and code, but also workflow. And in it, we can also store documentation, like data dictionary information, data lineage information. We can also manage workflow and deployments. The code we generate with Warescape is all SQL, it's all SQL. It's the primary load and transformation and persistence language that the Warescape automation tool generates. And it's optimized for Azure DW, Azure SQL, SQL Server, Snowflake, and a few other target platforms. And because we have this sort of best practices and different code templates for each different target platform, it also helps us migrate between the different platforms. We can build a data warehouse on, say, SQL Server, and then regenerate all the code and the DDL appropriate for Azure DW and use CTAS, for example, as an option for processing the data through, which wouldn't make sense so much on SQL Server. And whilst the SQL is the common language of data, it's not that great at figuring out delta loads from source to maximize data processing performance. That is where our partners at HVR come into play. They solve incremental real-time loading for us. And one aspect of modernization is reducing the data latency, getting data to the end users faster. And CDC, of course, really helps us get the data in front of the users faster. So what I'm going to do now is I'm just going to hand over to Sreevani at HVR, and she can talk to you more about HVR and CDC.
Perfect. Thank you, Doug. Can you confirm you can hear me okay?
Yes, yep, I can hear you.
Very good. All right, well, ladies and gentlemen, thanks for joining me and Doug on this session. I'm Sreevani Abbaraju. I run product management inside HVR. HVR is a premier log-based change data capture solution. Over the next few minutes, what I'll attempt to do is to share some of my own experience from our customers, knowledge we gain from our partners like Warescape. We have great partnership. Over a period of time, we've learned a series of sort of best practices, specifically at the data ingest phase of your data warehousing project, and I'll attempt to share those with you from different angles. So starting with data movement. In fact, Doug made a point earlier that business users, requirements from the business users are quite agile in nature. They do not know what they need until they see a copy of the data, right? So I'd agree, and I'd like to reiterate that it's imperative to make freshest data sets available to your business users. So not only they can make accurate decisions on their requirements for data warehousing, but it's also making key decisions on the business processes. That's where they've embarked on this journey in the first place. How can they improve their sales processes? How can they get more predictive about their customer behavior? How can they get more prescriptive about improving customer engagement? Those are the big business decisions they have to make, and making data available, a fresh data set available with minimal latency from application databases is imperative. It's no longer a nice to have, it's somewhat need to have at this point in time. And the key word there is the real-time nature of the data, right? So that's where solutions like HVR have been offering log-based change data capture. And I'd like to kind of compare and contrast different types of data movement technologies, specifically in the age of cloud data warehousing. And log-based CDC has been, CDC stands for Change Data Capture. Log-based CDC has been around for a couple of decades, the technology itself. Typically, it has been used in use cases like high availability, disaster recovery, or cascading, and so on and so forth. However, the strong emergence of cloud-native data warehousing technologies like Snowflake or Redshift, for example, have really jump-started the agile piece of the data warehousing initiatives. And these technologies like Snowflake and Redshift and others, and Azure DW, what they enable the customers is by removing the friction in the way of infrastructure costs, the time to deploy, administration costs, and essentially it's shortening the time to market. And it goes back to what Doug said, right? I mean, business users need agility, and it needs to be in the process end to end. And cloud native frameworks have pushed our customers and partners to rethink legacy processes and removing friction, not just in the deployment phase of the data warehouse, but just in the data delivery pipelines as well. So starting from ingestion, so assume you have a source application database. Your application is processing hundreds of thousands of transactions an hour, servicing your end users. It could be an e-commerce application, it could be a CRM application. The data is valuable. That's why you're collecting and compiling and loading them into the data warehouse to begin with. One of the methods traditionally being used for data loading into data lakes or data warehouses is the use of the traditional ETL technologies. And we're all familiar with this for the past 20 plus years, where you'd have a huge batch job, running typically every night or every few hours, and it consists of a select statement with some kind of filtering and sorting that is pushed towards the application database, like an Oracle or a SQL Server or a DB2, MySQL, whatnot. And the output of that query is a result data set. It could be in an order of terabytes if you're dealing with a very busy transactional database. But that result set, that large result set of over a few terabytes is pushed over the network to the staging area or the data lakes. And in some cases, it's operational data stores, right? The challenge with such an approach, it's multifold. First of all, you're already not meeting the real-time requirements from business because your batch job by definition is running a batch. So your data is at least a few minutes to a few hours or a day old, if you ask me. Second of all, from a database standpoint, think about the added workload that's being put on the already loaded application or the source database. And depending on how large the resulting data set is, and if the queries are not optimized, the application performance itself could suffer because it could pretty much take the system down, the database down. It's especially true if you have tables, database tables that do not have indexes or any kind of unique identifier. And if for any reason your query involves any kind of full table scans, that's in itself that in itself tanks the performance of the database and thereby the application. Also, in the age of cloud data warehouse, it's not just the overhead, but think about the network bandwidth that can be premium. So when you're moving large data sets at a time over wide area networks, that can quickly add up to your network costs. And then when you apply a one-time large commit to the cloud data warehouse, you're committing all that data into the destination database at the same time. And that's where your compute charges get spiked too, right? And most cloud providers today make their pricing models based on the high watermark of the compute usage. So these spikes can quickly add up as well from a cost perspective. Also, when you're delivering data into, say, data lakes that are servicing your data analytics needs for your data scientists, studying customer behavior, it requires tracking and analyzing events, not just outcomes. With traditional ETL process, what you're getting is an end state of a record without capturing what happened to that customer record over a period of time. You can go to the next slide, Doug. So what we have learned from our own experience working with our customers is that log-based change data capture technologies, and that's what we specialize in. But what we've learned is even though the typical use cases for the last couple of decades have been more on the master-to-master high availability type use cases, the technology itself is making a very strong comeback because of how it radically changes the game for the data ingest piece of your data warehousing project, right? So data ingest, using log-based CDC, really it's zero impact to the application database. Why and how is that? So let me talk a little bit. So when you have an e-commerce application, like in the early example, right, it's taking in orders, it's updating shipping information, billing information, it's canceling orders. All of these are translating into some kind of transactions to the application database, a DML or a DDL, depending on how and what kind of operations are pushed by the users. Now, all these databases, all relational databases, maintain a log for their own recovery purposes. In Oracle's case, it's Oracle's redo log. In DB2 case, it could be the general receiver files. MySQL could be binary log, SQL Server could be transaction log, so on and so forth. Regardless of whether or not that application database is part of a data warehouse initiative, the database is already creating this exhaust for its own recovery purpose. Now, what log-based CDC tools can do is to read from that files, not hitting the database, but really going to that database exhaust, capture committed transactions. Therefore, transactional consistency is enforced right off the bat. So take committed transactions, being able to reconstruct that SQL statement and then push that over to the fence as the transaction is immediately after the transaction is committed. So the data movement is incremental, thereby the impact of the source system is minimal to zero. And then once your database is not under extra load, you have a more predictable performance of your database, therefore predictable behavior of the application just from a database perspective. Right? And then because you're only moving committed and compressed change data, and I say compressed because HVR can do it. So when you're moving only committed and compressed data over the network, you're not seeing the spikes you would have typically seen when you're moving large data sets over a wide area network. And also when you don't see the kind of workloads that are being applied on the data warehouse at the same time, that you don't incur the kind of compute surges you would with traditional ETL processes. And more important than anything else, right? I mean, your data warehousing project should not interfere with your application users, and log-based CDC can and has proven in the field with our customers and our partners. Okay, and not just that, because you're capturing changes as they happen, you do have an opportunity to capture the historical information and do sort of a time key based analysis or a time series type collection of your data. Okay, so therefore, what I would like to share with you from a data ingest perspective is that we are seeing more and more customers deploy change data capture technologies, in the context of cloud-based data warehousing. You can go to the next slide, Doug, please. All right, so we talked about the technology itself. Let's see the kind of architectures you should be looking at. So this is another dimension to modernizing your approach, right? How can your data ingest solutions handle large volumes of data? So we all know that there could be, architecture for today's solutions that could be point to point, full stack, or distributed. And what we find, again, working with our own customer base in the advent of the cloud-based data warehousing, is that distributed architectures yield best when data volumes are pretty high, because by definition, you're able to process various stages of data processing across different nodes. For example, in HVR's case, what we see is, we could have you can have on the source node, you're able to process what tables and what specific what filters are part of the replication. So that kind of enrollment filtering happens on the source node. The compression happens over the network. And then we have a centralized location that can orchestrate replication into the target nodes. And the target nodes are responsible for doing the data type conversions, especially when you're going between heterogeneous sources and targets, where you have to convert data types, convert timestamps, and so on and so forth. From that perspective, the load across the data ingest pipeline is distributed across different nodes. And that goes back to the fourth or fifth slide that Doug was showing earlier, which had data volumes are a big concern today. And when you're moving data over network, distributed processing can really be your friend in order to achieve that minimal latency at scale. Okay. Also, what distributed processing allows you to do is to set up fault tolerance. So let's say I'll use HVR's case for example. So for whatever reason, if the source database, if the agent goes down on the source side, we can continue to capture transactions and cache them until the communication is established with the target. So therefore, you will never lose transactions. So again, distributed architectures are best suited for use cases like that. Okay. Also, with hub and spoke architectures, what allows you to do is to add unlimited, or at least allows you to scale the number of spokes or endpoints for an efficient, say, data consolidation or data distribution use cases. And typically in your data warehouse scenario, it's consolidation, where you're taking multiple data from multiple application databases and loading into a staging area, from which tools like Warescape can take it and automate them for your end users. Another consideration to think about is when data is in motion, most customers demand a way to verify data integrity, and that has to be done automatically. So when you're talking about databases with tables that are a few terabytes, reconciling data on both sides, verifying data integrity, these kind of operations are compute intensive. And again, having that distributed processing allows you to scale for such necessary operation. Okay. All right, can we go to the next slide, please? So again, going back to the end-to-end story, with Warescape's automation, what you're able to do is combine that with log-based CDC with HVR. You're able to capture real-time transactions as they occur and are committed on the source systems. The source systems could be relational databases, they can be on-prem, in the cloud, or they could be in file systems, relational, non-relational, structured, unstructured data. They can be orchestrated over a distributed network, distributed processing solution, and staged into data lakes, either in the cloud or in a cloud-based data warehouse. And solutions like Warescape, they can really allow you to get to that ambitious agile data warehousing. It's no longer an ambition, it can be a reality. So I can hand off at this point to Doug and let him talk about how data ingest alone is not going to help that real-time data delivery, right? You need that agile methodology downstream as well to make sure that your business requirements are met. Doug, over to you.
Thanks. Yes, well, Wordscape's been around for over 10 years. We work with a lot of customers, and we find that agility is absolutely crucial to building a successful data warehouse project, and we need to have that speed in order to support that. Now, universities, banks, retailers, manufacturers, surprising, you go to a financial services organization and you sit down and work out a set of requirements and then need to start building. And it is an agile process. They will change their mind once they start seeing the data come into the solution and say, well, I didn't realize we got access to that data, or I didn't realize you couldn't match this data to that data. We've got to adapt the design, adapt the processing to the data and to the requirements, and those are going to change during the project. So we need to have that agility. We work on the basis that requirements are going to change and our understanding of the data is going to change even after we start the project. Often the business don't know what they want until they see it, or they only ask for what they think they can ask for, and they will change their mind. So with an agile approach, we make a start and we build what we think they ask for, and then refine our solution based on their feedback. And we have to make these iterations short to remain engaged with the business. And we might end up iterating the design and processing several times, quite a few times during a project. Typically in that if you refer back to those layers of processing, it's more the user side of the data warehouse, the right-hand side of those layers, where we're applying the rules and the business perspectives. And during a recent proof of concept with who's now a customer, a developer complained that a project was actually not that fast by automating it. He could build it by hand just as fast. And that was because he had spent the previous 6 months analyzing data and testing designs before he started development. Well, his coworker correctly pointed out that they would have started 6 months earlier and iterated until the design was good with a more agile approach, and the project would be finished in 3 weeks instead of the 8 months it actually took. So that's where the main difference is. And the definition of what the development part of the data warehouse project is, well, he's obviously taking some liberties with that because they started 6 months earlier analyzing the data. And once we have something that we think is worth deploying, it looks like working with the business in development, we have something that they can use, something's going to provide some value, then we can also try and automate the testing and deployment of the solution. Automation tools leverage rich metadata describing the tables, code, documentation, workflow to package up and deploy from dev to test to production, or as many environments as we like. And this can be an entirely hands-off process. But in reality, though, although it could be a hands-off process, often we want a DBA to sanity check the generated refactoring deployment scripts before running them. Because hands-off deployment is great with an application, but it's not so much fun when you're dealing with billion-row fact tables. Altering a big fact table, sometimes not the best idea. So with automation applied to the design, the development, documentation, and so on, we can dramatically improve the time to value for a project. We can enable agile development. We can switch between technologies much easier, switch from on-premise to the cloud or from cloud to cloud. Go from Azure SQL to Azure DW, for example. We can switch to new architectures, make implementation of, for example, a data vault much, much easier because we can apply the standards and best practices for data vault during the design phase and also during the build phase. And we can also generate documentation. So we get something that's more consistently built, it's built across different platforms, and we can generate documentation at the end of it. And so the IT team that's tasked with building a data warehouse, they can really concentrate on delivering value from the data rather than spending too much time in the weeds of ETL development. Okay, well that concludes my slides. I'm going to hand it back to Sreevani just to finish off.
Yeah, so I think it was our attempt to share with you both from an HVR perspective and Warescape's perspective, how some of our customers have succeeded, by implementing log-based CDC alongside automation that helped them realize their real-time analytics goals, and that they've achieved by looking at more streamlined data processing, the various capabilities around initial data loads and making sure schema changes are captured. A full feature functioned log-based CDC solution can help you get heterogeneous replication up and running in a few minutes. The way, especially with heterogeneous replication, the challenges around different data types, different timestamps, converting all of that is a big nightmare. And solutions like HVR can help the customers achieve that in near real time. Because change data capture technologies are less overhead in the source database, we've found that our customers prefer using solutions that have minimal to zero impact on their applications, and CDC can deliver that. And again, from data staging from the source data being staged into the staging area, all the way up to delivering value, like Doug said earlier, value to the end users. Together, HVR and Warescape deliver significant value to our end customers. We have a lot of customers that have deployed this type of solution. And also from a maintenance perspective, providing graphical elements in terms of monitoring, alerting, and the ability to schedule and study the lineage of the origins, study the metadata. Together, in HVR and Warescape have helped the customers achieve their agile data warehousing goals. With that, I would like to hand to for any Q&A.
Yeah, hi, this is Rob again. We have a few questions. I'm gonna read them off as and kind of we can maybe hit a few if that's okay with y'all.
Sure.
Great. All right. So the first question we have is how much time does it automatically? Oh no, I'm sorry. How much time does automation actually save on a project?
Well, that's a good question, because with generating code and managing tables and managing change, that's going to save a lot of time in the mechanics of building it. But what it really allows us to do is start knowing we're going to change, knowing that we're going to understand the data better as we're developing the solution. So we can get started a lot earlier. So it comes back to that example we talked about earlier. There was an 8-month project. And maybe a month of that was development, in the traditional sense out of the 8 months, because they knew that change was going to be expensive, change was going to be slow. They're going to have to update the ETL mappings, they're going to have to update their target model, build them, test them, and that's a clumsy way or a slow way of making changes. So they went out of their way to spend 6 months up front to make sure they didn't have to make changes. Building prototypes and skunkworks and Excel and so forth. Whereas with automation tool, you can start much earlier because we can make changes so efficiently. We know we're going to make changes, but hey, it's really efficient to do that. And we're building something in the true agile fashion, something that's working, something that's populated, something that we can expose and socialize to get feedback from during the project. And so really the overall time of the project shrinks really quite dramatically through a combination of just speeding up development, speeding up redevelopment, but also starting earlier, because we know, hey, this is going to change, and I'm good with that. It's something that I can cope with using these tools.
Okay, thank you. Here's a question. Someone wants to do a trial version, download to do a POC. Do y'all provide that capability?
Yes, from a Warescape perspective, yes, we do. No problems at all. If they're going to try and evaluate it themselves, we've got some online training to stop them, getting stuck in the world of what on earth do I do now? Or we do, if the customer would prefer, we can do a remote or an on-site proof of concept with some of our guys helping. Sreevani, do you have any comment for HVR?
Yeah, absolutely. We welcome customers who want to prove out our solution in their environment. you're able to do a trial download. All you got to do is to give us some information, and we'll send you a key to be able to trial download.
Okay, thank you. There's a question about the PDF slides. I think we'll be posting the PDF slides to our website, so y'all stay tuned for the upload of the video and the PDF to the website. Another question is, how close to real time can you get with these tools?
I can take that. So the data delivery into the staging area using our solutions, we've been able to get sub-second latency to our customers, especially if your databases are optimized. The question is, if you have the right amount of network bandwidth, especially in the cloud use cases, then latency from capturing a transaction, processing it, because we're compressing and encrypting over the network, the data movement is quite efficient. And like I said, in some cases, we were able to achieve sub-second. Doug, do you want to comment on the downstream processes?
Sure. So once the data's landed in the environment and on this ongoing, almost stream basis from CDC, the processing within the data warehouse, applying business rules, we typically turn to micro batches, leverage the best practices of the database platform on which we're running these processes, and we can often run that sort of every minute or maybe even less than that, but every minute's usually good enough. And the nice thing is we're only taking data out of the foundation layer, which we know has changed since the last time we processed the data. So the actual data movement is really minimized, because as HVR or CDC publishes the data to the ingestion zone, it's tracking when that data changed. And so even if it's not on the raw data, we know when the data arrived in the data warehouse, and we can use that to minimize the amount of data we're applying the rules to publish into the end user layer of the data warehouse. It makes it much more efficient and incremental process right the way through from ingestion all the way through to the final stages of aggregation and publishing to the end user layer of the data warehouse. So probably every minute is a good expectation for the star layer and the aggregation layer of the data warehouse.
Okay, this is a question. They currently have a data warehouse they're having to implement, and their question is, can Warescape go ahead and absorb their current data warehouse, and is there a big migration effort?
Good question. Well, we can import existing table structures. So hey, you've started to build a data warehouse, so you've got a mature environment. We can pull in all of the tables associated with that data warehouse and add metadata to it so that we can generate documentation. We can manage deployments. But the code that you might have written, our tool's not going to be able to interrogate your code and figure out what it's doing. We can call your code, we can import your code, but really we're not going to be able to track what you're doing inside that code, because there's so many ways of writing. You might be using CTEs and all sorts of crazy things in your code that our tool's just not going to understand. In a clean environment, we might decide to redevelop it, or we might decide to leave it, if it's working, leave it as it is and just copy in the code or import the code that you've written into the tool and just run it, and only need to redevelop it if for some reason we need to make changes to it. So yeah, we can import a lot of what you've built. Some of the stuff you've built we can run, but we won't be able to reverse engineer the logic from that. So we would have to rebuild some of the code if we did want to make changes to it using our tool.
Thank you. So another question is about sample, do you have some sample use cases in architectural designs?
Sample use cases. Well, probably we don't publish that kind of thing. We got, of course, case studies. But we don't have things like a pre-built higher education or a pre-built retailer data marts. We don't have those. We find that often it's quicker and easier to work through from scratch if we're going on site to help a customer build out a proof of concept, for example, or help them get started on their data warehouse. Often we can go to a whiteboard and describe the end user layer, the star schema or the tables that we need to build, and work our way back to the source. And we've got a lot of tools or a lot of functionality in our tools that will help us get there very, very rapidly. So normally it's tailored to the customer rather than a sort of a standard off-the-shelf sort of use case design, pre-built design.
Okay, thank you. Another question here, are these tools for on-prem? Are they for off-prem or hybrid, or how do these tools work?
I can speak for HVR. The way HVR is designed, it can be deployed completely on-premise. It could be deployed completely in the cloud, or a combination of both. And that was the point of having a distributed architecture as well, where you can flexibly have the installations. You could either deploy HVR on your source machine if it's on-premise for a direct reads, if you will, or you can install it on a remote server that's either on-prem or in the cloud that can do remote API-based captures from the source database. Same thing with the apply piece as well. You could have HVR installed on the target machine, or if the target machine is, say, like an RDS, a relational database as a service, then you can deploy it in a EC2 instance or an Azure instance that's closest to the target database. If you don't want to do either, you can flexibly deploy any components remotely or on box. So for HVR, there is no limitation in terms of the combination of where you want to where your source and target databases are and where it can be installed.
Yeah, and from a Workscape perspective, we support the cloud databases natively, so Azure DW, Azure SQL, Amazon RDS, if you're going that track. We have the templates that support those cloud databases natively, the SQL dialect, SQL functions, the best practices, and so forth. It is a Windows Developer Studio, so there is a development studio that you'd install on Developer Workstation, and there's a Windows-based scheduler as well, which needs to be installed somewhere, either on-premise or up in a VM in the cloud. So yeah, a lot of our customers, maybe 50% of our customers that have bought in the last couple of months would be entirely up in the cloud. They install everything up in the cloud. They might have the FAT client installed on their local machines, or they RDP into it in the cloud VM.
Thank you. So here's another question. They're asking about HVR and Workscape. How does it differ from other tools like BIML Studio or BIML Flex?
Well, so BIML would probably be more closer to Workscape. So at their heart, they're trying to achieve the same things. BIML Studio and Varigence and Mist, they're trying to achieve the same thing, trying to automate the donkey work of the data warehouse. So conceptually, very, very similar. How they do it is obviously different. They use BIML, they're generating SSIS, they're generating tables, they're generating all the bits and pieces of the data warehouse. We don't think it's quite so well-rounded and is easy to use as, say, Workscape, but conceptually the same thing. We're trying to automate the donkey work of building a data warehouse.
Well, add to that, the CDC technology from HVR, it helps you when you're creating SSIS packages. Again, those are mini batches, right? So what HVR and Workscape together can do is provide that real-time component on top of the data warehouse automation. So that is something that I would call out as well.
Cool.
Thank you. Here are a few more questions we have left here. What do you see as a typical, what do you see as the typical latency for real-time loads? A
typical work, okay, well, let's assume your transactional database is take Oracle database in this case, right? Sometimes the customers could have a batch load running on their database that could generate a significant transaction overhead. That's when you can expect a few seconds to a minute latency. And again, it's so hard to quantify it, partly because there's so many ways you can optimize the performance. For example, in the case of HVR, when you have a source HVR agent installed on the source machine, and when you have another agent that's been deployed in the cloud or on the target machine, inter-agent communication is significantly compressed, up to 10x compressed. But if you're preferring a remote capture, for example, or a remote integration, for example, then you will not be able to benefit from the compression capabilities. Also, when it comes to cloud data warehousing, if you can set up an HVR instance closest to your RDS machine or a Snowflake machine, that would yield the highest performance, because again, inter-agent communication is compressed. There are ways to parallelize the integration process. Within HVR, data movement between source and target is set up in channels, pipelines, for example. So if you find out that there is an individual table that's under severe transaction load, and that's the one causing bottleneck, you can actually move it out into a separate channel and parallelize the integration process. There's many ways to optimize depending on the configuration that you're going after.
Yeah, and that's the hard part, getting the data in there across the network and identifying changes. Once the data is ingested into the data warehouse, which is all the process that Sreevani just talked about, then moving the data through the layers of the data warehouse are usually nice and fast. It's using set-based operations in the database where you're able to use incremental logic to move just what's changed. So Wescape has got the easy part of that scenario.
Okay, thank y'all. We just have a few more. I'm gonna kind of run through them here. Next one is, can you do a CI/CD DevOps?
Yes, so from a Wescape perspective, yeah, we can do hands-off deployments. We can script a deployment, blow away a test environment, move stuff across from dev, run through some tests. If they pass the test, maybe we could deploy to production. All hands off. All the facilities are there using a metadata-driven deployment process. But as I mentioned earlier, that can be tricky when you've got large amounts of legacy data in the target environment. Maybe hands off. You'd want to be careful about that, because hey, generating refactoring DDL and running it against a data warehouse with large amount of historical data, that can be something you want to DBA to sanity check before running the refactoring scripts in production.
Thank you. So we're kind of at our end of the meeting, and there's one announcement I really need to make. First of all, I want to thank everyone for attending. We had a lot of people show up today, and it's great when a lot of people take time to learn new technologies and come to our chapter. Second of all, we have a few prizes we'll be giving away, so check your spam, check your junk mail. You may be the winner, and that would be really cool, to get a prize. And next, I want to thank Doug and Sharice for giving the presentation today. Thank you.
No worries.
All right. Well, with that, we're gonna end it, and I look forward to everyone coming to the next webinar next month, and I hope y'all have a great evening. Thank y'all. Thank y'all for coming.